And we've distilled this down to a couple of simple parameters that you can look at. One that we call ionic strength. It's like an aggregate measure of concentration. Leachates aren't one solution. They're not, or one constituent. They're not sodium and chloride. They're a whole potpourri of things. Usually I can distill it down to about 6 different cations and 4 different anions that are important. And we get a measure of total concentration. That's called the ionic strength. And then we have another measure, which is just a relative abundance of the monovalent cations and the divalent and polyvalent cations, a ratio, essentially monovalents to higher charged cations called RMD. And so you can imagine as ionic strength goes up and the RMD goes down, this is more concentrated or more divalent, we'll get very different types of behavior. And if we look at leachates, it turns out that these two simple to calculate parameters, and you can send your leachate to a lab. They'll give you back the geochemistry, and you can calculate these. I have a spreadsheet here to illustrate that in a minute. That'd be part of John's part. But almost all leachates tend to fall in a band that look like this. And this is a solid waste data set that we created with Waste Management's leachate database, so about 10 years ago. Those gray dots, that's MSW leachates, right? And it turns out that these two parameters capture most of the behavior for conventional bentonites.